Hello friends, today we are going to solve a particular problem of single slider mechanism with respect to IC center. IC center is one of the most important technique which is used to solve the velocity of that particular mechanism. So IC center is known as instantaneous center method, which is developed by Arnold Kennedy. So a problem is like that: a single slider mechanism having crank and connecting rod of 200 and 800 mm respectively locate all eye center when the crank rotates at 40 radian per second. Angle of crank is 30 degree from IDC. Find the velocity of slider and connecting rod. As we know that they have said a single slider crank mechanism, so first of all we have to draw a single slider crank mechanism. So we will take care of a single slider crank mechanism. Now before drawing the single slider crank mechanism, we have to select the particular scale, that is 800 mm equals to 10 centimeter. So my 80 mm will become 1 centimeter. You can use the suitable scale as per the requirement. There is no compulsion for the particular scale. So first of all, we have to draw the base there. So I have drawn a base there. So we have to fix up a particular point, that is for crank. From crank, they have said that there is an inner dead center of 30 degree. So we have to draw a line of 30 degree from this particular point. So this will be my 30 degree. Then the length of the particular crank is 200 mm. So with respect to scale calculation, it will become 2.5 centimeter. So I have to draw a line of 2.5 centimeter. From that particular point, there will be a connecting rod which will pass and give me the particular slider. So the length of the connecting rod is 800 mm. So with respect to scale, as we have taken, that is 800 mm equals to 10 centimeter. So I have to draw a particular line of 10 centimeter. So we got the point of 10 centimeter, that is our connecting rod on which our slider will get lie. So join these particular points. Okay, now this will be our link number 1, link number 2, link number 3 and link number 4, that will be the slider. Now as it is required that the first step to solve this particular kind of problem will be to find the number of IC centers. So first of all I have to find my IC center. So for IC center there will be a particular formula, that is n small n minus 1 divided by 2, where n defines the number of links. Within this particular mechanism there are 4 number of links, 1, 2, 3, 4. So my IC will become, that is 4 minus 1 divided by 2, it will be 6. So it means within this diagram there will be 6 IC centers. Now after that we have to create a table there, that is our second step. Always try to create the table such that you will get the name of the particular points. Link eye center, that is 1, 2, 3, 4. The number of links you have to notify here and we will get the number of eye center, that is 1, 2, 1, 3, 1, 4, 2, 3, 2, 4 and then last 3, 4. Now I have got my eye center methods, that is eye center points. There are total 6.3 plus 3 6, as we have drawn that the number of points will be 6, and we have got the name of that particular point. So our next step will be to locate the fixed and permanent eye centers, that is I12, that will be my fixed one, I14, that is again the fixed one, this will be my I23, which is the permanent one, and this will be my I34, as 3 is joining with 4. So I have located my 4 points, that is eye center. Then again, within the problem the slider is present, so the slider movement or the slider path of eye center will always lie to the perpendicular to the slider movement. If my slider is moving or sliding at horizontal direction, so its eye center path will be perpendicular to it. So we'll get the perpendicular. Same thing, whenever there will be a slider within the problem, then all the fixed centers present in the problem will have the perpendicular lines with respect to slider. So there is a fixed point, so I again have to place. These perpendicular lines have come due to the slider, so I have to give the name to the particular lines, that is I14 at infinity. This will be again I14 at infinity. So I14 at infinity we have get out. So we have got 4 eye center points, 1 2 3 4. Now overall there are 6 center points, so remaining 2 points we have to create it. So with respect to remaining 2 points, if we try to create it, we have to draw a circle there. Then number of links are 4, so 4 points, 1 2 3 4. So 1 2 3 4. Join these 4 centers. Now the points are, we have drawn I12, 1 4 2 3 3 4. Now the remaining will be 1 3 and 2 4. So for 1 3, the 1 and 3 are the diagonal, so join the diagonal. Now with respect to triangle, that is 1 2 3 and 1 4 3 will give me the point 1 3, or the simplest way is for 1 3 you have to create the points, that is for 1 3 if you consider the upper triangle, that is 1 2 and 2 3, 1 2 and 2 3. Then for lower triangle 1 4 and 3 4, 1 4 and 3 4. That means these 4 points will place my eye center 1 3. So 1 2 and 2 3, as 1 2 is here and 2 3 is here, extend this particular line such that it will join 1 4 and 3 4, 1 4 and 3 4. So we have to locate 1 4 and 3 4. This will be my 3 4 and this is my 1 4, which is going up to the infinity. So we have to join this particular line. Now at this point we are getting I13, that is our 5th IC center. Now the remaining is 2 4, so we have to again make a diagonal. So my 2 4 will get from 2 4 will be from 1 2 1 4 2 3 3 4, 1 2 1 4 2 3 3 4. So this will be 1 2 1 4 and this is 2 3 3 4. So join the line there. This will be by I24. Now we have located all the 4 eye center which are required in this particular mechanism. Sorry, all the 6 centers. Now within the question they have asked to find out the particular velocity of slider and connecting rod. Velocity of slider and connecting rod. As it is required to find any linear velocity, that link should be particular point. As 2 having fixed point, that is link number 2 having fixed point, that is here for crank. Hence we are using length of the crank to find out the velocity of this link 2. But if we take the case of link 3, the link 3 is the connecting point of link 2 and link 4. So in that case, for the rotation or the movement of the link 3 is with respect to the I center, that is I13. Hence the velocity of link 3 will be taken care of with respect to I13. So first of all, we have to take care of the slider, that we have to find out the velocity of slider and velocity of connecting rod. As slider movement is horizontal, slider is moving in this direction, so the velocity of I4 or point I4 is lying on the link 4, that is my link 4. So I14 will lie on link 4. Hence Vi24 will equals to V4. As we have to find out the slider velocity, we have to find out the slider velocity, that is V4 equals to quotient. As slider movement is horizontal, that's why we have to take the consideration of I24, which will give the velocity of slider, because I24 lie on the link 4. So for I24, this will be my I24. We have to first of all find out the velocity of it. So as we know, velocity equals to R into omega. So I24 will become, that is radius or the length, that is 1224, because it is residing on link 4 and this is the path of slider only. That's why we have drawn here as a perpendicular. So distance of I12 to I24 into omega 2. As we know that the value of omega is given as 40 radian per second, that is for omega 2. So it will become, so we have to measure this particular line and multiply with respect to scale. After multiplying with respect to scale, that is with 40, we will get 4.8 meter per second. So therefore V4 equals to 4.8 meter per second. So we have got the velocity of the slider, that is 4.8 meter per second. Then with respect to it, they have asked to find out the velocity of the connecting rod, that is for link 3. That is, they ask for the angular velocity, not the linear velocity. So our next thing is to find out the angular velocity. So for angular velocity, there will be, first of all we have to take care of the, that is angular velocity of link 3, that is I23, as velocity of I23 equals to omega 2 into, as 23 is there and we know the omega of this particular link, that's why we have taken the consideration of this first link, that is from I12 to I23, and we have to multiply the distance. As we know the velocity, angular velocity, angular acceleration of this particular problem, that's why we are taking consideration of this link. So omega 2, same wise for I23, if it lies on link 3, as I23 lies on link 2 and link 3 both, so for link 2 it will become omega 2 into I12 into I23, that is distance. If we taking the consideration of link 3, that it will become I23 equals to omega 3 into, now we are considering the in the link 3, so I23 to I13. We are considering the omega 3 because the link 3. So now we have to measure the particular link. It will become almost 11.7 centimeter. So multiply it with scale. So with the ratio of it, that is omega 2 I12 to I23 equals to omega 3 I23 to I13. Omega 2 it is known, that is 40. Then I12 to I23, as we have taken is as a 2.5 centimeter, multiplying with the scale ratio, then we will get as a 0.2 equals to omega 3. We have taken the consideration in meter. Omega 3 into I23 to I13, that is, this will become 11.7 centimeter. Now 11.7 centimeter into 80, so it will become 900 something. So within meter we have converted as 0.93. So as 0.93, and we have to, final task is to find out the omega 3. So omega 3 we will become as 8.60 radian per second, and this will be our final answer. Most thing we have to note it as the link point, that is I23, lies on both link 2 and link 3. When we are considering on link 2, then velocity of I23 will become omega 2, that is for link 2, into distance of this particular crank link. And then when we are considering on link 3, then same velocity of I23, that is velocity I23 will become omega 3 into this distance, that is IC, because as we have already discussed that there is no fixed connecting point is there, as within the crank the fixed point is there, that's why we are considering this link. Now within this link, that is link number 3, is the connecting rod, not the fixed link. So in this case we have to take I13 as an IC center, which will try to rotate this particular link. That's why we have considered omega 3, I23 and I13. And we have to remember the formula, that is velocity is radius into omega. That will develop the particular solution.